So today, for today's webinar, we have with us Gary. Mr. Gary Bateman is the Managing Director for Lap India. And Gary, over to you.
Thank you, Shreya. And good afternoon to everybody joining us from Asia. Good morning to those joining us from Europe. It's a pleasure for me today to welcome you to this discussion on global trends in factory automation on behalf of the entire Lap India team. This discussion today has been offered as a component of the 17th Stuttgart meets Mumbai Wine Festival, which this year celebrates 53 years of partnership between the two cities. Unfortunately, due to COVID, this year's wine festival has been presented in a virtual format. But still, I have great pleasure in saying that we are joined today in Stuttgart by Mr. Andreas Lapp. Mr. Lapp is chairman of the board of Lapp Holdings in Germany, as well as chairman of Lap India. And in addition to those formal positions in business, he holds the role of honorary consul of India for the states of Baden-Württemberg and Rhineland. And through his support, he has provided significant support for the promotion of the Indian arts in Germany and has assisted many Indian companies gaining a foothold in Germany. As a long-time benefactor of investing in manufacturing in India, Mr. Lapp has played an important role in growing the business in this country. As a business exhibiting strong family values, Mr. Lapp has been instrumental in growing the business into a leading global supplier of integrated solutions in cable and connection technology. And it's an honor to have him joining us today. COVID over the last year has had a significant impact on the way business is conducted globally. In many respects, changing business models forever, driving the adoption of new technologies to address past deficiencies and to protect operating models going forward. Key amongst these technologies are the proliferation of Internet of Things applications and its particular application in automation of manufacturing processes and facilities. To expound further on this subject, it is my pleasure today to introduce to us our keynote speaker, Mr. Georg Staworwy, the global CTO of the Lap Group. Mr. Staworwy has extensive experience in industry, spanning a technical career from research through to executive management. Within the Lap Group, Mr. Staworwy has overall responsibility for global manufacturing operations, for innovation and technology. With such a broad expertise, I cannot envisage anyone better equipped to deliver our keynote address today on factory automation in manufacturing. With that, it is my honor to hand over to Mr. Georg Staworwy, CTO of Lap.
Thank you, Mr. Bateman. Namaste, namaskar, vanakkam. So a very warm welcome from my side, and thanks for having me. Thanks for inviting me to be with you in India. Although today I'm here in Stuttgart and we are enjoying springtime here. So today, if you are invited to any tech talk or you participate in any tech talk, of course, you can't go without speaking about industrial Internet of Things. This issue is huge, it's big. So it's a very wide technological field, but also commercially a big game changer. According to latest studies, the market for IoT-related technologies and services is around 11 trillion euros by the year 2025. And somehow, we are all somehow involved in this issue. So of course, you as being in machine building, system integration, factory automation, distribution, whatever domain you are in, you can't go without. So being invited to speak about IoT and smart factory is also a risk to fail, because what to talk about? The field is so diverse, and here's my try for today. I will try to structure the issue a little bit and get down to some basic principles of IoT. You may feel this is already common sense. My experience is it's not. Somehow people tend to be blinded by technology, but we should think about the basic principles. Of course, I will also share some trends that I see. I will explain you a little bit the lab offerings, our contribution, what we can bring to the table. And I also want to share with you some of my personal conclusions. And of course, I'll invite you also to get into some interaction after my keynote, as there will be some room for question and answers. Yes, we are speaking about wine during the wine festival, and I have to confess, I'm also a big lover of wine. If I drink a good wine, I perceive winemakers as artists. People that have mastered a technology, a process, a cultural heritage that has been cultivated for hundreds of years. Now, if you look from a technical perspective to winemaking, and now excuse me to speak a little bit in Six Sigma language, you have a lot of very volatile key input variables. So to manage that process, to come out with a great wine at the end, is in that respect really art, because you need to manage all these critical input variables. So I found a quote about making good wine, and this quote is actually not from a winemaker, it's from an IT professional, from Mr. Das, VP of Infosys. And he's relating to how we can manage a process with a lot of high volatile key input variables to come to a great output. And this is an interesting aspect because IoT is taking a very strong foothold in farming industry as one of the first successful applications. If you think about making wine, it's not only about the output, it's also about the process efficiency. So regarding to studies, the loss of wine due to plant disease is around $60 billion every year. Yes, and we know that, we can experience that in our neighborhood. There is variability in climate, uncertainty of irrigation, and then there are pests and crop disease and so on. And now we are only speaking about wine. We all know the bigger challenge is to feed the world. And if you think about all the inefficiencies, technically speaking, in harvesting, then you can understand that IoT is, especially in agriculture, going through the roof. So transforming vineyards with IoT, what does that mean? That means control of irrigation. It's not a problem today to measure humidity or irrigation in the soil. It's no problem to get information about weather forecasting. It's no problem to install, even in your vineyards, hundreds of sensors and try to learn and understand and control this process. For a human being, this is art. For technology, it's not. It's all about having small control loops. Now, being a wine fan, I still believe that wine will remain to be art, because at the end, whether we like the wine or not, this is done in the cellar. But even, of course, in the cellar, you can monitor temperature, humidity, whatever you need. So IoT is a big enabler in this use case, but it's also a big enabler in our factories to have smaller control loops and to get to new insights about our processes. Let me get back a little bit to the history of IoT. If you look to already history books, if we speak about technology, the first roots are maybe in the beginning of the 80s. when students started to, so to say, control a soda vending machine via a first type of World Wide Web, which was not there. But then officially the first registered IoT application was a toaster at an American university, where students checked how the color of the toast, and regarding the color, then stopped toasting the toast. So this was the first IoT related control loop that we know about. Actually, it took 9 or 10 years more until the official expression Internet of Things was invented, although the technological development was earlier than that. It was a British scientist who started to speak about Internet of Things, although he was using RFID, which is a passive component. So those days, products could start to talk, but so to say, they didn't know what to say. The lab group has invented in 2007 a cable with RFID tags in the insulation. So that was our first contribution to IoT, so to say. Honestly speaking, that was never a commercial success. Looking back, it's very plausible to us. The iPhone was not there. It just started 2007, 2008. So the problem at that time, from a technological perspective, was if that cable knows something and it's written on the RFID, how do you get that out of that RFID tag to make decisions? So, and yes, our promotional activities were to say, well, we have the speaking cable. But as I said, the issue was what to say. And then it was 2000 when the entire topic took off, when we saw first applications in consumer electronics. In this example, it's by LG, who announced by the year of 2000 that they will introduce smart refrigerators. And I remember those days, I didn't have a clue what that would mean. Today, we are getting closer to understand what this is all about. And for the rest of the development, we all know that. That's already history. In 2008, we reached the point on the globe where we had more digital devices than human beings. And just as you will find other milestones, in 2018, since 2018, every car in the European Union has an e-safety device, which means is connected for emergency purposes. But you all know that car OEMs today collect constantly millions of data and information from our cars driving through the street. That's the world we are living today in. And this is a development which is just 20, 30, maximum 40 years old. So now, as I'm saying, we are flooded by ideas where to implement IoT, what to do with it, and we are still learning. But I feel it's very important in discussions to step a little bit back, so to say, and look of what are the basic principles. Let's not get nervous about this thing. Let's not get overexcited. Go back to the basics and understand what are the basic principles. It's, of course, you need data. You need to gather data, which is mostly from sensors or from systems. Then, secondly, IoT is all about networking. You need to transfer that information to other places. So IoT, the Internet of Things, means every element of a connection or every element has an own IP address. So the ability you can speak to any device or any part. And then it's an interesting topic. Then you need to access this information. Could be by a human being at the interface of an MES system. Could be, of course, processing of data. Because then at the end, the fourth element is decision-making, interpreting this data and taking decision. And this is why, of course, edge computing, for instance, is the big topic. But before you come to that topic, you may want to make sure that you get the data. And then also not to be flooded by buzzwords and whatever. you can apply these basic principles to any domain, and then people start to talk about IoT, and maybe they have in mind the wearables, the watch, the smartwatch that you are wearing. Then there is IIoT, and this is, I think, for us today, the big topic, as most of you are also coming from the factory side. But then, meanwhile, I read also about IOMT, so it's in medical domain. And whatever we may find other buzzwords, and it's getting an academic discussion to say, okay, what is Industry 4.0, what is IoT, what is smart factory about, and so on. But you can always go back to the basic principle I've shown before. Now, the issue is, if you want to apply IoT, you are looking to a huge map of providers of technology. The intent of this slide is not to make you read out all the logos of companies involving into that. And this map is constantly growing. But of course, you can structure a little bit what the offerings are all about. First of all, you need to become clear about the vertical you are speaking about. As I've mentioned before, you can look to consumer goods, you can look to medical goods, you can look to factories, you can look to buildings, the smart building issue. So factory automation is just one small aspect, and you have hundreds of companies playing in that part, including also on the actor side, so to say, on the automation side, robotics and so on. And then you have, so to say, the horizontal dimension, where it's more about the enablers. And there we are speaking about platforms, we are speaking about interfaces, connectivity, software, and so on and so on. So from lab side, and for today's talk, we should simply look at factory automation, and we should not underestimate the industrial connectivity and the network connectivity as the basis, so to say, the veins, the nerves of a smart factory application. Some figures about the Indian market. India today already is holding 5% share of the entire global IoT market. I mean, you have more than 1 billion people, but you're also a very much technology-driven country. And as you see on the left side, if you split that roughly up between industry and consumer, you can figure out roughly half of that market in India is related to industry. And then in the pie chart, you can see to what different applications. I've stressed a lot in the beginning agriculture, which is around 8%. But then, of course, manufacturing is the big chunk, together with utilities. So that amounts already of 40% of the entire market. Now, there was an interesting study conducted in your country about the question what the post-pandemic area will bring us, and in which areas and application we can expect an accelerated application of IoT. With little surprise, you can see that around 82% of healthcare-related companies responded that they intend to accelerate. And as you go through that, I think it's very plausible to us why certain verticals are ranked quite high, which is very much related also to what we experience now during the pandemic. Consumer goods, which is booming. Also finance, insurance industry, construction, also same issue in Germany. Now during the Corona pandemic, construction industry is booming, infrastructure projects are pushed by the government. Automotive is last in this ranking. And I think it has nothing to do with, to interpret that automotive industry might be more reluctant. I think it's simply due to the fact that especially automotive industry has been a strong driver, and they are in automation on a much more mature level than other verticals you can see above. So let me speak a little bit about the lab way and lab contribution to smart factory applications. First, I want to talk a little bit about the network and the backbone of IoT. Then I would like to address a couple of topics regarding the industrial communication and application in the smart factory environment. Last but not least, also the question to what extent our products have an own IP address and can contribute. And therefore, I will also share some examples from the lab world about smart products that we offer. So first, and very importantly, the core network, the backbone. The backbone is, of course, fiber optics cabling, 100 megabit up to 250 megabits. So this is, of course, fiber optics in different forms, can be very robust for the long distance carrying of information, can be also more smaller related, as you know, that the trend, we can see that trend of fiber to the home. So the fiber optics is getting closer to our houses. Today, we talk a lot about software, artificial intelligence, and so on. What a public discussion is somehow maybe underrepresented is the fact that we still have a huge issue in the backbone. In Germany, you will find areas where if you want to start a company, you better ask first whether the backbone is there. The German telecom providers will bring the broadband to your house, but only if you live in an area where they can reach their return on investment. If they don't reach it, then it's simply not interesting. Out of this observation, the German government released a program of 11 billion euro to install broadband in the entire country. And it's the same in your country. Your Prime Minister Modi announced last year that there is still a lack to connect 100,000 panchayats. So I learned this is around 600,000 villages with broadband until 2023. So let's think about the basics and still what we need to do to really bring IoT to every corner where we want to apply it. One game changer in IoT will be 5G. As lab, we have looked a lot into wireless technologies. Of course, you can assume, oh, this is cannibalizing cables. But what we learned so far is that all technologies that you find have some disadvantage. May it be latency, may it be security, may it be accessibility. Now, first, when we read about 5G, everybody goes like, oh, this is everything. Short latency, reliable, how is that possible? But it seems that it is possible. Now 5G is going through the roof. Will there be 5G in every corner of your country, in every corner of Germany? I'm not sure. But of course, the concept will be that you will set up ecosystems where you have 5G accessible. And then there is, of course, also you need to connect 5G. So there is, of course, power to the antenna. Yeah, there is frequency to the antenna. And also this is a huge market. So what this young gentleman is holding in his hand is one lab solution to support 5G, which is a box with skin top glands, with terminal blocks inside, and with the marking you need to do for the installation. And we won this project with a famous Nordic telecommunication provider because of the wind load that this box needs to hold on these antenna masts. Yeah. So if people are starting to talk with us saying, oh, 5G is a threat to lab, it is not, for two reasons. One is, among us, 5G is also a market for us. But secondly, of course, we will support you to connect everything that should be connected with cables and support you to connect everything that should be connected with 5G. Therefore, my engineers are involved in 5G activities in the German machine building industry, VDMA, in order to define for which applications you should better use a cable and for which applications you should better use 5G. Okay, then now let's go into the factory. Let's look into the factory. Yes, of course, for the connectivity in a factory, we have, this is what we like. Yeah, we have a broad portfolio of products to support you. But which products do we have in our portfolio? How do we select what to put in? Because it's huge. And you know that concept of minimum viable products? And we converted this a little bit to speak about minimum viable portfolio. So what we are doing is we look to a specific application, like in this case, a bottling station in food and beverage. And then we ask ourselves, what does this customer need in specific to run IoT? Which are the typical protocols he's using? And then we break that application up into technical applications, like you can see on the right-hand side, the connection between the machine cabinet and the cleaning machine. And then we follow the physical connectivity and ask ourselves, okay, what does a customer of a bottling station need? And therefore, we are going from application to application and add those products that you need in the IoT connectivity if you're coming from a certain application. Because the big topic is how to navigate yourself through the jungle of products. I was speaking about 5G as a game changer. There is another interesting game changer, which is single pair Ethernet. I guess you have heard about this. This is, I think the name is misleading, yeah, because it's technically a description of an Ethernet cable with only a single pair. Okay, from an application point of view, that's not important. From an application point of view, it means that you can connect a sensor, which is typically connected via a bus system, and then convert it to the Ethernet protocol. You can connect that sensor, so to say, directly to the cloud. And then there is beauty in it because, yes, it's a cheap cable, it's a small cable, because wherever is a sensor, you need a miniaturized cable. And yes, it's easy to connect in the field. Now, single pair Ethernet is a game changer which demands standardization. And therefore, we have joined a network of strong partners from the connectivity industry, the single pair Ethernet industrial community. And together with them, we are working to further define the standards. You will know that the ISO standards are already defined, but you may also know that there is still some uncertainty which connector to use and what implies for switches, for instance. We have already released a single pair Ethernet portfolio, and you can trust that within the next years, we will have a full portfolio of single pair Ethernet devices to support you. So in a nutshell, if you look to lab capabilities for IoT, it goes all around the connectivity that you need. It's, for instance, of course, RJ45 field mountable and IP67 standard. We have Etherline cables, bus cablings for all different protocols. Yes, we do have Ethernet switches. We have an NAT router that you need, so to say, to manage your own network of machinery. We can offer you secured VPN gateways together with a partner. And then there is optical fiber, not only in the backbone and the outside, but also as assemblies in the factory, including all optical fiber accessories. Now, let me get back to one thought that I already addressed, to become blinded by technology. If you look from technological trends, what are the trends in IoT? It's augmented reality, plant layout simulation. You read a lot about digital twins, big data analytics, artificial intelligence, cloud computing. So if you go to a conference, if you read the newspaper, if you talk to your neighbors, this is what we like to talk about. And then when we have talked about this, we feel like, oh, I'm so small, I still have to learn a lot. Then we go home to our factory, and then we look below the water and feel, oh, okay, maybe the beauty and the miracle seems to be above the water, but there is homework to do below the water. And actually, this is where the headache starts. One of my messages to share, to discuss with you is that we shouldn't worry about the application level of IoT. There are hundreds of companies developing software and so on. For your issue, you will find somebody to have a good application. But you need to make sure that you have the fundament. You need to make sure that you have a network in your factory. You need to think about how to connect machines with different PLCs and make sure that they end on an OPC layer with the same structure of information. And then there is physical interfaces, software interfaces to be managed. And according to what we collect in the field, around 30 to 40% of network problems you detect in the field are due to the physical layer. So therefore, make sure that you do the, so to say, hard, dirty work about the homework before you start to dream about artificial intelligence. Now, some thoughts to share also from my own experience, as of course also the lab factories in Giggany, in Bhopal, but also around the world, how we can make them smart, and want to share some experiences. And the most important experience is you need to know what you want. So the entire process at Lab started with a discussion what we would consider a smart supply chain before we speak about a smart factory. And then we were starting to think about a vision that availability would mean that we can access and deliver to our customers any physical inventory of our cables. Can be in one of our warehouses in India, but why not from any third-party logistics? Why not from a channel partner? Then, of course, we are working in a global company. We need to also coordinate the factories in a network. If I have capacity constraints in the cable works in Stuttgart, why shouldn't I give that order to Giggany to produce? How can we manage this? And then there is a big trend of customization, could be in packaging, in labeling. And therefore, first, we wrote down our vision of what we want to achieve. And then we drilled it down to our factories and clearly defined what decision, so to say, if you look back to the beginning of my talk about to really know what you want and where you want to go to, we defined different elements of where we want to have decision-making supported by IoT. Can be quality, traceability, time tracking, monitoring, reporting, operator guidance, machine connection. So actually, customer first, as we all like that, and it's always true and always right. But it's important that you not get stuck in a technology project, but you navigate to what is really customer benefit, could be internal customer benefit also. So let me conclude with some smart products from the Lab Group as also contributors to IoT. As also many of you are looking into predictive maintenance, we also are offering now a product that is predicting the failure of a cable. So it's about an algorithm, it's about understanding what's happening in aging in an Ethernet cable, and that intelligence comes today in a box. So you can connect that box to any dynamically loaded Ethernet cable, and the box collects the data, brings in the intelligence, and predicts when that cable will fail. So that box, of course, then will transmit that via Wi-Fi or Bluetooth. Then that can be sent to a cloud. So whoever wants to utilize that information. Of course, this intelligence doesn't need to come in that box. It can also be integrated in a switch or in a PLC. But this is for the first time that we can really predict failure of a cable. Most of you may not need this, because you're looking at the value of a patch cord of a cable and you feel like, okay, what is the cost of this box compared to the cost of the cable? But of course, you need to think about those applications where downtime is crucial and very costly. Think about medical devices. So one of our first field installations is in medical, where a failure of a cable can harm a human being, can be decisive on live or die. Okay, it doesn't need to be dramatic as this, but think about a big vessel. We were approached by a customer building big vessels, and they had an incident where the entire vessel went on emergency mode because of data transmission errors. These are the cases where it pays off. It's not a product that you will want to have in every application, but it's a product that some of our customers urgently need in order to assure uptime. We are speaking here about a small Ethernet cable, but there is other cabling in the world, yeah, like on a drill rig. This is on the picture you can see just an installation at the land to test cables. The real installation is offshore on an oil platform. And there you have a huge cable loop. Speaking about a cable loop, in that case also involves hydraulics, pneumatics, anything that I need. So if some people believe a cable is a C product, for them it's not. And of course, same logic here. We have added to the cable sensors. We are measuring humidity, temperature, resistance. So to compile via a microcontroller, and then wireless, of course, as it's offshore, to collect information about the condition, which offers us to offer services to the end customer. So these are examples where you can see that also a cable itself can and should deliver information in a smart factory. So this was a short overview, a short insight into IoT and about the lab offerings. And my main messages and takeaways should be as follows. First of all, please, please, please don't be flooded and overwhelmed by technology. The big development in the past 5 years is the technology is there. Don't worry about that. The second takeaway should be start to play, like on this picture. Start to play, because no matter how many consultants you will find, actually you need to go through this learning curve. Third takeaway, yes, it's not about playing, it's also about hard work. And maybe that's not so appealing if in your company you're saying, hey, let's talk about the network, because people would expect you to talk about artificial intelligence. But think about the order, think about the hard work. And last but not least, as it's the wine festival, take a glass of wine, step back, and really think what you want to achieve with Smart Factory. Without that plan, it leads you to nowhere. So thanks for listening. I hope I've gave some inspirations to you. And now I hope that we still have some minutes for questions and answer. So please, Mr. Bateman, Shreya, take over. And let's see whether we can still answer some questions in the room.
Okay, thank you, Mr. Stawawi. Yes, thank you very much for that insight. I know this is a deep and complex subject, and without a doubt, there's going to be a lot of questions. I see we've had a couple come in already, so maybe we can start with those. But before that, anybody out there with questions, if you could perhaps just pose them on the Q&A functionality on the Zoom screen. You'll see at the bottom of the screen, in the middle between participants and share screen, the Q&A functionality. If you can use that to pose questions, and then we can take it from there. Mr. Toby, the first question was, we're talking about 5G. And yes, we're very early in learning about 5G and implementing 5G, but there are some countries now evaluating 6G. As a company, has LAP considered how and if it's possible to support this faster functionality?
Well, I think still for 5G, we are still in the phases to really get it to the ground. I only know up to now few applications where it's really already adding value. So I'm not speaking about as consumer. Even as a consumer, the big question debate, at least in Western Europe, maybe it's similar to India, is it's nice if you have 5G on your mobile device, but how much are you willing really to pay for this? Because somebody needs to pay for it. And so, for instance, in the neighborhood of LAP, we have a new Daimler factory for the new S-Class, and that is already an ecosystem on 5G. But I don't know that I don't know that many cases of 5G. So somehow, like, of course, every year we screen new technologies, and there might be already a beginning discussion about 6G. But I think the beauty is exploit and take a very young technology first. And of course, that is 5G. And as to LAP, we will fully involve in this technological development, not because we will build up antennas on 5G. That's not our business. That's other people's business. But we fully trust that if we speak about reliably connecting the world, Gary, I mean, 5G is for the first time that it can be reliable in wireless transmission. So our focus will be to really bring 5G to the ground. And I think this is priority one.
Thank you. I hope that answered the question there. So the next question really was more of an operational question. So there's a concern in India that a lot of these special cables are still imported from Europe. And this leads to some logistical concerns with regards to extended lead times, delay in delivery because of infrequent shipping, particularly impacted by the pandemic, and the vagaries of the exchange rate. How does LAP intend addressing the import of specialty cables in terms of supply into India? I don't know if you want me to perhaps take a lead on this one.
I think first of all, the entire supply chain is LAP is built mainly on the principle of local for local. This is why the LAP family has invested so much in India, but also in Korea and China and Indonesia and so on and so on and so on. Think about the heavy load of cables. So the basic strategic setup is local for local. So that means, of course, today we do import special cables into India with all the disadvantages for you. But this is not our strategy. If you have a chance to visit our factory in Jigani, you will see a lot of capabilities to go to produce specialized cables within India for India, including armoring lines that we have for heavy instrumentation cables and so on. So strategy-wise, and this is an interesting aspect, because we are currently in very intensive discussions about the strategy of the LAP Group for 2027. One focus will be about what we are calling now value-added services, which means despite that big beast of platform economy, which we also need to entertain, we see a growing demand also in specialized cables. And the strategy is clearly to expand the capabilities within India, to, of course, also in India, serve the local market with local capabilities. I'm thinking, and Gary, you're in a better position to answer this, I'm thinking also about the solar cable, which is not a specialized cable, but this is an example where we just localized all the capabilities into India for that growing demand. And this is clearly our strategy. Lab India should have all capabilities to serve the Indian market as best as possible. Will there be exceptions? Of course, maybe in some cases we need to import, but we want to avoid that. But Gary, please,
thank you. Yes,
maybe you want to add something from your side.
Yeah, no, I think it's spot on. What you said about being wanting to have a strategy where local for local, but there are, of course, some economic factors to it. If the volume is not justifiable, it does not make sense to include that product into the localization program. So yes, every year we have a program of whereby we have a range of products that we localize to bring the technology into India. But there's always some issues that may prevent it. One is insufficient volume to justify the financial of localizing, and also in some instances there are cables that require specific testing capability, which may not be available in country at the moment. So in those instances, the technology will still remain in Europe. Outside that, as you illustrated with the solar cable example, we always have a program to localize, and there's additional programs this year as well. So thank you on that one. The next question that came up was with regards to predictive maintenance. And the question revolves around, can we have predictive maintenance for power, low voltage cable or flexible cables?
Give me some time and then yes. So it's clearly, I mean, from a customer perspective, first of all, I need to share this. We are very, very proud about our predictive maintenance solutions. I mean, we are carefully observing also what's entered in the market. I think we have managed to develop a great technology. But from a customer perspective, I'm fully aware that the beauty will come if you can, so to say, predict failure on all your low voltage cabling. Yeah. So yes, we do have filed first patents also on that technology, but it's not ready to present or to go to market. But I think from a customer perspective, absolutely, because those use cases that I mentioned where downtime is crucial, that relates also to the power connection, needless to say. So hope as I may get invited in future, Gary, maybe I can present something.
Okay, well, that invitation stands, and we will definitely take you up on that and then organize the relevant interaction with customers. So, Mr. Hedge, thank you very much for your positive comments on the presentation and on your food for thought, really, about the cost effectiveness of smart logistics. I know you didn't pose it as a question, but I think, Mr. Tolwe, I don't know if you want to comment on that. I think we've seen in India, from the initial work we have done in terms of implementing smart logistics, there's definitely a cost benefit. And there is a potential return on investment to justify smart logistics. Maybe you can just expand on that a bit further.
Yeah, sure. I mean, if we are speaking about our industry, first of all, I mentioned the consideration as having a C part, but then I like to add it's an A functionality. But still, if we're speaking about that components business and services around that, then of course it's about logistics. Logistics is a key factor in our industry and for our scope. And therefore, I think we have, if you look to our capabilities and our variants, for instance, for packaging and so on, and we even have a brochure just around different logistical services we can offer, you know that this is a crucial part for the company. One of the most massive projects we have done was actually 3 years ago in Lab India, when we reconsidered the footprint of the warehouses. Yeah, and to optimize the warehouse to assure certain delivery times to you. But of course, as we see Amazon, Alibaba, whatever you name them, the hunger is there to have logistics even more aggressive. Even more aggressive means in terms of service to you, but also to reduce the processing costs inside. And just as an example, it is Lab India within the Lab Group to take the lead, for instance, on tracking of deliveries to the customer. As consumers, we are used to that, right? We look on our smartphone and see where is it and when is it coming and so on and so on and so on. And let's assume this is also true for some of you, maybe not everyone. For an OEM, it's not maybe about 8 hours. It's more about being very reliable on a certain point of time next week when to deliver to the dock. But for us as an MRO, it's very crucial to where you're counting hours. Yeah. And therefore, Lab India is introducing also the technology to track cables and so on. But then if you look, now I'm speaking about logistics, but if the question is related to the entire supply chain, then wow, we are speaking about 160,000 products that the Lab Group is offering from 20 own production sites and some trusted partners for technology. And we need to coordinate all of this. And of course, it's huge to think about the options and the possibilities we have introducing technology. Hope that this answers the question. I think it's hard to quantify on the savings you can get or whatever, but I think we know from consumer perspective the stretch is there, the expectation is there, and therefore, of course, the smart supply chain is the guiding North Star, so to say, I think, for any company as it is for Lab.
Thank you. So Mr. Farm wanted to know, do we have any particular partner that we work together for 5G? He referenced Nokia base stations as an example. Or are we agnostic to the vendor of the 5G equipment?
Yeah, some of our, well, we do deliver to some of these big companies, and therefore, so to say, for instance, Ericsson in Sweden, where we deliver equipment to them. And as I've showed, for instance, the box are somehow involved in the engineering. Other than that, it's partnering from an application level. But as I said, we are not in a position to develop 5G itself or the transmission of 5G itself. This is not our business, and this is not our competence. But of course, we do liaise with the big operators and installers of 5G to optimize product offerings and support for reliable 5G connectivity.
Yeah, thank you. And then Mr. Shah wanted to know, why is it necessary to have additional devices to detect physical failure in fiber optic cables? Is it not possible to have switching devices, connectors, or end junction devices that are made intelligent to have this functionality instead of adding on an additional device?
Sorry, I don't get the question, because fiber optic itself can be used to detect interruptions. And therefore, for fiber optics, you will not use the box I've presented. Yeah, as you know, fiber optic itself is, for instance, in high voltage, used to detect interruptions.
So I don't know whether I think perhaps we may not have. Sorry. No, I was just saying that I think perhaps, Mr. Shah, we hadn't answered your question maybe in the way you intended. So we have your contact details through the registration, and we will be in contact to maybe understand the question a little bit deeper to ensure that you get an answer that is satisfactory.
Yes, please.
Another question is just to understand. So this revolves about manufacture of 5G compatible cables in India. I think at this stage the answer is no, and I'm not sure in terms of the cables manufactured in Europe at the moment, particularly for 5G applications. Maybe, Mr. Sawa, you could just expand a bit further on the portfolio of products relating to 5G.
Actually, if we're speaking about the data connectivity side, unfortunately, yes, as of today, nothing of that is produced in India. Yeah, strongest footprint for the cables needed in 5G is still in Europe. We have within the group a center of competence in northern Italy, where we have allocated that expertise. But also, this is not directly the question, but still I would, as in the first question, would relate to our strategy, local for local, that of course, this is also an important perspective for the Indian market. And then as to the portfolio, sorry to add that, there is a little time lag. Of course, you look to a lot of cabling, but also not to underestimate it, as I've tried to show you on the picture, is also about from customer perspective. 5G means in most cases adaptation of an existing antenna, so to say a retrofit. So the question is how you can facilitate that retrofit in the field. And therefore, we also need to consider non-cable, non-connector, non-active component side, but also passive side to say, okay, can we deliver a plug and play box, so to say, to do the retrofit? That's why I've shown you a picture that we also have that capabilities regarding the physical part of boxes, cable glands, skin tops, and so on.
Thank you. So as I look at it, I think we've probably timed it well. We've come to the end of the questions that we've been asked, and it comes to a perfect time to perhaps close this discussion this afternoon. Mr. Stolby, I would start by thanking you very much for your time this afternoon, for the insightful message you've delivered, and for the interesting questions that it has drawn.
Yes.
And I think as people reflect on today's presentation, there's going to be many, many more. To our business partners who have joined this afternoon, we at LAP appreciate the time you have spent with us, and we hope it has been of value to you. And as you reflect on today's presentation and discussion, there may be additional questions that come to mind that we haven't perhaps addressed fully today. So I would like to take this opportunity to invite all our business partners out there to reach out to the LAP India team should you have any questions or you wish to engage further on this subject. We would welcome that deeply. So with that, I would just like to end by thanking everybody for joining us today, to wish everybody well, with good health. I know in India, there are still patches of COVID flaring up. So with that in mind, I just wish everybody a safe stay for yourselves and your families. And thank you very much for joining us this afternoon. Your time is greatly appreciated. Thank you and have a wonderful day.